Welcome back, guys. Now we're doing simultaneous linear equations. This is basically grade 10 work. So what people normally have a problem with is that they either love this section or they totally hate this section. So what we're going to do now is basically I'm going to show you the two methods that they talk about, which is the substitution method or the other method, which is called the, what was it called? I can't even remember what it's called. I think it's called, what's the other one called? Oh, elimination method. That's the name. Oh my god, someone could have just told me that, really. Okay, so let's start. So I'm going to do the substitution method. So the substitution method, and in the middle, on this side, I'm going to do the elimination method. Elimination. Alright, so when you do, you can pick whichever one you feel like doing, but the most important one is the substitution method is most stressed upon, because when you come to functions where they say find the intersection, then that's basically where you do simultaneous equations to find the intersection. So let's start number one. So when I first have this, I first write out my equation. So 2x plus 3y is equal to minus 2, right? Then I'm like, okay, when you have substitution method, you need to convert each of your equations by making y the subject of formula, right? So here I'm going to say y the subject of formula, or you can make both of them equal y the subject of formula and then make them equal to each other, or you can take one that has a 1 in front of the variable and substitute it into the other. So if you look at this one here, let's say this one here is only 1, but can you see this one here? It has a 1 in front of it. So what I can do here is I can say, right, x is equal to positive 2y plus 6. So I took the negative 2y and I put it onto the other side, and I call this equation number 2. Now I can say this, sub 2 into 1. When I sub 2 into 1, I'm going to say here, so wherever I see x, I'm going to put this in. So there's 2x. So I'm going to say 2, open brackets, 2y plus 6, close it, plus 3y is equal to minus 2. Now I'm going to solve. So what I'm going to do, I'm going to have 4y plus 12 plus 3y equal to minus 2. So here I'm going to have 7y is equal to minus 14, y is equal to minus 2. When you get something like this, you need to substitute it into one of the equations to get the other one. So I'm going to say substitute y equal to minus 2 in equation 2 is more easier. So I'm going to say x is equal to 2, open brackets, minus 2 plus 6. Therefore x is equal to minus 4 plus 6. Therefore x is equal to positive 2. So what is my two values? It's going to be y is equal to negative 2 and x is equal to 2. If I had to write this as a coordinate pair, it would have been 2 and negative 2. So simultaneously they'll have a point where they intersect at. So that means this one line here and the other line here would have come to a point called 2 and minus 2. Right? That's the point of intersection, the simultaneous equations. Now another way to do this would have been, so I'm just going to do it quickly at the bottom here, but I'm not going to show the whole method, I'm just going to show you a short one, is if I made both y the subject of formula. So I would have said 2x plus 3y is equal to minus 2, 3y is equal to minus 2x minus 2, y is equal to minus 2 over 3x minus 2 over 3. And then I would have had the other one to be 2y, because it was negative 2y is equal to negative x plus 6, y is equal to positive a half x, and then that divided by that is negative 3. Then you see this is a y, this is a y. I would have let this equal to this, and then I would have solved. But this is not recommended. Why is this not recommended? The reason why this is not recommended is because when you have something like this, it's very easy to get your answer wrong because of the fractions. Many of us can't do fractions, so we would have struggled with substituting and would have been struggling with solving for x. So if you are doing substitution method, you should always look for the easier alphabet to substitute into the other equation. So here we had x as 1, so we could move this here. Right, don't go with fractions. Fractions are very difficult for some people. Now if I had to do elimination method, to do elimination method, you need to have the same x's or the same y's. So let's look at my two graphs, so two equations. So can you look at my two equations? I have 3y's and 2y's. I have 2 x's and then I have 1 x's. I don't have both of the same. If I had 2 x's and 2 x's, then I could just say this minus that. If I had 3y's and I had 3y's here, I could have said this minus that, but I can't because they're not the same. So I need to make one become the other, or sometimes you need to make both become each other. You know, like how when you solve for fractions, you try to make them equivalent to each other. So it's the same thing we're going to do here. We're going to try to make this equivalent. So I'm going to call this equation number 1, call this equation number 2. Now I'm going to say, right, I'm going to taking equation number 2 and I'm multiplying it by 2. Why? If I multiply by 2, I'm going to get the same x's. So it's going to become like this. 2x, everything is being multiplied by 2, minus 4y is equal to 12. And now I'm going to call this equation number 3. Okay, now I say take equation number 1 and minus it from equation number 3. So 1 minus 3. So I'm going to say 2x plus 3y is equal to minus 2. I'm going to say minus, then I'm going to say open brackets, 2x minus 4y is equal to 12. And now when I do this, when I'm doing the minus, the signs are going to change. So 2 minus a 2x gets cancelled out. 3y minus a minus 4y. This minus and this minus becomes a positive. So 3 plus 4 now becomes 7y. Minus 2 minus a 12. So what happens? It becomes equal to minus 14. You see how this part and this part is exactly the same. So this part here and this part here came exactly the same. So then you say y is equal to negative 2. And then what would I do? I'll take this and substitute it. So I'll take the same thing and do this method here where I say substitute into one of the equations and I solve for x, and I would have gotten the exact same thing. So you decide what you would want to do. When you're doing elimination method, you have to make one become the other, at least the same x's or the same y's. You just need to get rid of one variable and then you can solve for the other. Right, now I'm going to give you one to do, so I hope you are ready. Right, are you ready? I don't know if I'm ready. Alright, let's see. Yeah. So sleepy, hey? I'm very sleepy today. No, I don't have another one. Never mind. Oh wait, let me check. Alright, there's one here, okay? Are you ready? So it's let's make it a little bit difficult one. So 3x plus 5y is equal to 8, and x minus 2y is equal to negative 1. Alright, solve for this simultaneously. Pause the video and then come back and see if you actually got it right. Okay, so pause. Don't cheat. Okay, so let's start now. What we're going to do here. So I'm going to do both methods because some people will be like, I like elimination method. No, I like substitution method. So we're going to do both methods so both people don't have to cry here. Alright, so we're going to say 3x plus 5y is equal to 8, my equation number 1. We're going to say x minus 2y is equal to minus 1, that's equation number 2. But I'm going to take equation number 2 and I'm going to rearrange it. So I'm going to say x is equal to positive 2y minus 1. Okay, so I can call this, I don't have to call this equation number 2, I can call this equation number 2 because it's exactly the same. I never manipulate it at all. Now I'm going to move on and I'm going to say, right, I'm going to say substitute equation 2 into equation 1. So I'm going to say wherever I see an x, I'm going to put in equation 2. Plus 5y is equal to 8. So we're going to get 6y minus 3 plus 5y equal to 8, then you're going to get 11y is going to be equal to, what is going to be here? 11. So y is equal to 1. Then I say substitute y equal to 1 into any of the equations. So I'm using 2 because it's more easier. So 2 times 1 minus 1 is 1. So x is equal to 1, y is equal to, what's my coordinate pair? It's 1 and 1. Now if I had to do it elimination method, I would have gotten the same answer. So let's do it here. 3x plus 5y is equal to 8. That's equation number 1. Then I'm going to take equation number 2, and I'm going to say, right, I'm just going to write it out. Because some people will be like, no, why did you do that? Right, so I'm going to times this by how much? I need times it by 3 to get rid of that. I could have times, you see, this is awkward to say 2 to 5, so we'd rather take one where it's more easier. So times 3. So when I times everything by 3, this is going to become 3x, this is going to become minus 6y, this is going to become minus 3. Then I'm going to call this equation number 3 because I manipulated it. Then I'm going to say 1 minus 3. Right, so 3x plus 5y is equal to 8 minus open brackets 3x minus 6y is equal to minus 3. Now when it's a minus sign, all the signs on the inside changes, okay? So here it's going to become 3x minus 3x is 0. 5y minus a minus 6y is positive 6, so 5 plus 6 is 11y. Negative and negative is positive, so 8 plus 3 is 11, therefore y is equal to 1. If I did the same thing here and substituted into one of the equations, I would have still gotten the coordinates 1 is to 1. Alright, I hope you understood that. That's last year's work. Now we're going to move on to this year's work.